Hello and welcome to Notes 1.7, where we're going to be talking about bivariate statistics here. So in bivariate statistics, as the name sort of suggests, we are going to actually be comparing two quantitative variables with each other. So one of the ways that we do that here is we can use a scatter plot. A scatter plot is a display that shows the relationship between two quantitative variables measured for the same subjects. That's what's going to go on that blank there. On an XY coordinate plane. So it's got to be the same subject. So you can see over there we got some data about study time and tests. And I didn't take the study time from my first block class and then grab test scores from my third block class. This would be study time and tests for the same block, the same students. So how do you make a scatter plot? We don't do it a ton, but this sort of breaks it down for you. So you want to make sure that you sort of scale your axes so that way the data shows up appropriately, and label those axes with a variable name and some units. And if you have some data that is kind of close to zero, include zero, but ultimately don't always include zero just because. You don't have to have the origin on your scatter plot. You can sort of, zoom in toward the actual window. So, and then you just plot each point as you would in XY coordinates. So for example here, you can see I've already got my ready-made scatter plot here. And so study time, I have some values that are close to zero, so it made sense to me to put zero in and scale. You can see along the x-axis there, I have it written out by twos, but each little box is a half an hour, basically. And then the test scores, though, they don't drop close to zero at all. The lowest one is 45. So I started my scaling at 40 there, and just sort of went up by fives for each grid line there. And so that's what you can do. If you're never quite sure, actually, if you're looking at the data, you have a lot of data. Again, we don't actually make scatter plots a lot, but it happens sometimes. You can always use your calculator. So let me show you really quickly how you can use your calculator to make a scatter plot. So let's take a look at how we make a scatter plot, okay? So to make a scatter plot, what we're gonna do is we are gonna go into the stat menu here, and we're gonna go to our lists and press edit. And we're gonna put in our data. I already have it all in here, so you should do the same while I sort of explain really quickly. So I put all of the study hours into list 1 in the order that the table presents. And then I put all of the test scores into list 2 in that exact same order, making sure I'm pairing together the exact points that are there, 5 to 90, 2 to 75, not mixing up the order. That will definitely result in you getting a different scatter plot and maybe seeing a completely different thing than we're about to see. All right, so then you're gonna go into your stat plots. Remember, you're gonna hit second, the Y equals button, and that takes you to your stat plots, okay? You're gonna go to that first one. Make sure that it's on. If it's on off right now, you can go over and just press on and press enter, and it'll turn it on for you. And we don't want a histogram. We don't want any of these box plots. We want this very first thing here, which is the scatter plots. You can tell it's scatter plots because it's just some dots out there. And I put all of my list 1 things along the X. That's what we're gonna do here. And all of the list 2 stuff, that's my Y. You can change, the different ways it looks. I like the little squares. And then you can change your color if you happen to have that option. And then in order to get to it, we're gonna hit zoom and then 9. That's our bread and butter when it comes to it. And so there you go. You can see that that is our scatter plot. It's not showing the x-axis or y-axis super well. It doesn't seem like it's scaling things too well. But what this is nice for actually is getting you an idea of like, what sort of window should I look at? And so when I press window, I can sort of see that like, okay, they started the lowest x value at 0.3, so I would call that like a 0 basically. And they go up to about 8.7. So like I should probably get up to at least like a 9 if I can. And then Y values, the lowest value was like a 45. They went down to 36.5, so like when I did it, I was like, oh, maybe I'll start at 40. And then they get up to 103.5 because I think the biggest value is like 95. So that makes sort of sense. But the scaling, they don't really rescale very nicely for us, so don't worry about that. But yeah, So there you go. That's a good way to sort of check to see if your scatter plot looks good. And we'll do this a lot, actually, is make them on the calculator, not usually by hand. Great. So hopefully that helped you sort of see how to do that. That's the most common thing you'll end up doing when we come to bivariate statistics is you grab the calculator, you plug in your data, and then you come up with the scatter plots on your own. So just like with univariate data, with histograms, box plots, we can describe these using particular features of what we're sort of seeing. So this is going to go over the different things. So just like we had CSCSO, this one, the acronym is SDFOC. The acronym's not as important and the order is not important. It's just making sure you hit all the things that you're supposed to be hitting here. First thing to talk about is the strength in your data, the strength in the scatter plot. So how close are the data points sort of together or forming some sort of trend? So the first example that we have right here is something we would determine very weak. You can sort of see how there's like, this overall trend here in the data, but those points are not super close to that trend line I just drew in there. But on the other hand, this other one here, I would say that's a very strong association we're seeing there. You can see that if I sort of follow it, it's not a linear function that sort of the trend is, but if I draw in sort of that trend line there, a lot of my points are very, very close to that trend line. So why don't you take a moment and head back up here and look at our scatter plot. What would you say it is? Fill that in, and I'm going to continue along here. Pause it if you need to. The next thing to discuss is direction. Direction lets us know whether overall we're seeing an increase in our variables, sort of as the x variable is increasing, the y is, or is it reverse? X increases and then the other one decreases, y decreases. So if that's the case in this scenario here, where we're seeing them increase together, we call this positive direction. And you could probably guess what we would call the other one. Overall, we're seeing that the variables are sort of moving opposites of each other. That is a negative association, negative direction. And it fits sort of the lines I just drew in there. On the left side there, if I were to find an equation for that, it would have a positive slope. And if I were to find an equation for the other one that goes downward, that would have a negative slope. So that sort of tracks with sort of how you would view the slopes of trend lines. So take a moment again, look at our scatter plot at the top there. What would you say the direction is there? And then we got form. F is for form. So we have sort of just two buckets that we do this in. Some people kind of get caught up and try to go with more buckets, and there are more buckets, but for this example here, we're just going to go with these two different ideas, which is if your data points sort of fall along a straight line, we call that a linear form. But on the other hand, if you see something and you're like, a straight line doesn't quite match it, I see something that's a little more curvy, we're just going to call it non-linear. And as we know from much of our math careers, that there are many nonlinear things, and so that would be sort of a further exploration. But for just describing, we're just going to put it into one of those two, linear or not linear. So again, you can go back up to the top and look at the scatter plot. What would you say for that? And our final thing is to talk about outliers. So outliers, just like when we're talking about, with histograms and box plots, outliers mean the same thing here. Points that fall outside the overall pattern or trends that we're sort of seeing here. And so here we can see that our points are all falling along this nice little line. But we can see that there's one little point down here. And that one would be an outlier. This one has one outlier to it. And oftentimes when you're describing, you might try to describe where that outlier is approximately. So maybe in this particular case, I would say that, oh, there's an outlier at about, 95 comma 10 or whatever it ends up being. And if it was labeled for me, then I could add also some units to those 95s and 10s. This one doesn't give it to me. The other one over here, we could see that it seems like the overall trend is that little curved trend line there. And there's definitely one outlier here, and here I'm going to call that one an outlier as well. Unlike with, univariate statistics, where they have that 1.5 times the IQR rule, there isn't really a hard and fast rule here. So it's really on sort of your judgments. So I'm going to say that there are 2 outliers here. And again, if I had some numbers there on the axes, I could sort of say at, this point and this point, and say like, this many days and this many square centimeters of mold on the cheese. Kind of a gross example, but whatever. So anyways, why don't you take a moment to see does our scatter plot up at the top have any outliers? And if so, where would they be? Cool. And so we're going to try to piece this all together. I'll sort of get you started here with sort of how to describe what's going on here. So the last thing, of course, we need is context. And just like with the univariate stuff, I always like to start my sentence by saying exactly what the context is. So that way I get that out of the way. So I probably would start this as saying like the association between test scores and study time shows or is or something like that. And this is where I start listing out the things like what did I say for its strength? What did I say for its form? What did I say for its direction? So try finishing that up as best you can in a full sentence. And then we'll talk about all of these when we come in for class. What did we say for each of these sort of descriptive words, and like what was the sentence you sort of pulled together? All right, so let's move on to the backside now. And on the backside, we got some other stuff, some things to sort of talk about, because a common question sort of is like, how do you know what goes on the X versus the Y, or like, how do you know if it's strong or it's weak? So we're going to kind of go through that. So first, let's talk about the extremes. You don't really see these too often because they're kind of boring types of problems to deal with. But I just wanted to point them out for you. So if you ever see a scatter plot like what you see right here on the left, that's a scatter plot that we would say shows absolutely no association between whatever 2 variables these are, okay? Because there's no noticeable form and there's no noticeable direction. I could sit there and try to go like, oh, I'll draw in a line that sort of looks like this, but somebody could come along and draw in a line like this and they're not any more right or wrong. Some people may be like, oh, it's kind of curvy. I don't see how you could defend anything about what form this has or whether it's positive or negative. It is just a random scatter of points. So there's no association between whatever these 2 variables are, and thus boring to sort of pay attention to. On the other hand, on the complete other end of things, this is a scatter plot here that is showing us a perfect positive linear association, okay? This almost never happens in real life, okay? It is never the case, really, that you're going to have a model that follows the data perfectly. It just simply doesn't happen if you're actually dealing with collecting data with some, where it's like not confined by rules, Maybe when you're talking about like physics and there's certain rules that go along with that your data might be perfect because it's following very specific rules of physical, the world and whatnot. But for the purposes of our class, we're never going to really see this. All right, so then, as I was saying, some people have a hard time sort of knowing like, well, what do I put on the x versus the y? And so this should hopefully help you out here. So the x-axis is usually the explanatory variable, and in our class it'll always be that. It's called the explanatory variable because it's thought to sort of be like what explains or predicts the other variable. So in the example that we just did about study time and test scores, it makes more sense to put study time on the x-axis because the amount of time that you have studied should sort of explain sort of how you score. It's not always a perfect thing, as we saw in our scatter plots. It's not perfectly a positive association there, but it does a pretty good job at trying to sort of explain that or predict that. And then along the y-axis, we call that the response variable because it is being explained by or predicted by that variable along the x-axis. Be careful, some people use the words like independent and dependent variables, okay? That's something that is used maybe like in an algebra class. But independent and dependent have very important definitions and meanings in probability. And so we don't want to start using it here and then getting confused about, the probability stuff that's going to pop up in not too far future here. So let's see if you can understand which one is which. So I have two examples here that I'd like you to think about here. So beach visitors and water temperature, okay? So the temperature in the ocean, how many people are coming to the beach? Which one do you think is the thing that is explaining the other? That would help you determine what's the explanatory variable, and then the other one would be response. Same thing for weekly exercise and resting heart rate. Which one do you think explains the other? Which one is the response to that other variable? Fill those out. We'll talk about them in class. Now, the last thing we're going to sort of hit on here is a way to sort of determine what is our strength, okay? I don't know if you noticed, but on the front side, all of those sort of descriptors, they can be subjective, okay? Especially the strength one. The strength one I feel like has the most subjectiveness to it all. And so how do you sort of know whether something is strong or it's weak or it's somewhere in between? And there's actually a number that helps us out with that. The number is known as the correlation coefficient. The correlation coefficient. So the correlation coefficient, also known as the R value, we use a little r to represent it, it sort of tries to give us that understanding here. So I have a little scatter plot here, over here in the corner that sort of comparing the heights and weights of some people. And so for this particular one, R is 0.6440. Okay, so that kind of gives you an idea of like that kind of number is attached with something that kind of looks like that. Okay, so here we're going to go through some fun facts about R, so that way you are very clear on what it tells you. So first off, it's always going to be a number between -1 and 1. And it has a sign of a negative or a positive because that tells you the direction. And the number that's actually there, the magnitude of that number, tells you sort of how strong the relationship, the association is. So if something is perfectly negative, well, that would be a -1 as the R value. If every single data point landed perfectly on sort of like your trend line, your line of best fit, and you were decreasing, it would be -1. On the other side, though, a perfect positive would be +1. You can see there, all those data points there on the right side line up perfectly with a single trend line. But those are very rare, almost never going to see cases, and so we'll see things that are more in between. So bumping back over to the left side here, we see that we have a decreasing overall trend, but it's not perfectly strong. It's still strong though. Points are pretty close to any trend line I kind of draw in there. So I'd call that like a -0.7. Jump back over to the right side again, and another example of something that is strong, but positive is there. You can see it's a little bit stronger than the negative 0.7. I'll say that that's about 0.8. And then we work our way in. Back over to the left side, this is a bit weaker. We're going to call that a negative 0.4 because it still has this sort of overall decreasing trend, but not as strong as the one that's just to the left of it. And then back over here on the right side, we'll call that a 0.3. I can see that overall it is sort of increasing, but it's very weak. It's not very good at all. 0.3 is not a good, strong sort of association we're seeing. And then, of course, the one in the middle there, it is very difficult to sort of notice. This is an example of where I'd say there is no association between these things. And so the R value that we give this would be 0. So if you ever get an R value that is 0 or very close to 0, it means there really is no association between these two things. So there you go. You would never have to try to guess at these R values, okay? I'll explain in a little bit sort of how it's calculated and how you can calculate it. But sometimes it's just given to you and you just have to sort of realize what it's saying is about sort of the direction and the strength of the original scatter plot and the original data. So some other things to note about correlation is that correlation is unaffected by the switching of your explanatory and response variables. So if you mess it up and you're like, I put all my values on the X axis, they should have been on the Y. Guess what? If your calculator spit out an R value at you, it's going to be the exact same. And that's the same for rescaling. So the original data up here that I had puts the height in inches and the weight in pounds. If I change those to be in centimeters and to be in kilograms, the R stays exactly the same. Another thing to mention is that correlation only measures the linear association. The formula that we're going to look at here in just a moment is only about the linear association between variables, okay? So it's possible that you can see a strong relationship exist in a scatter plot, but then when you go to find R, it maybe doesn't show a really high number, and you might be kind of confused by that. And that's because probably what you're looking at is not linear. So over here we can see there's this very strong relationship going on here that has sort of like this, upside down U shape, this little arch to it all. But if I were to plug those points into my calculator, or if I were to try to use a formula and find R, it's not going to be that great, okay? And because of that, it's all about the fact that the formula thinks what I'm dealing with is supposed to be fit with a line, and that was not the right call at all. So we'll talk a little bit more in the very, very, very far future about what do you do when your data is not aligned? Is everything just tossed out and you can't do anything with it? No, there's more you can do, but we'll talk about that in the second semester. So a lot of people want to know, how do you really calculate R? And I forgot to delete some things as I was sort of making this worksheet. So if you want to cross off those sentences because it references things that aren't actually there. So what you can do is you can use the formula that's given to you on the formula sheet. If you want to pull that out, so I'm going to bounce over there real quick. So right here, this R equals, this is the correlation coefficient. That's how you calculate that. Fun fact though, don't do it. Don't actually do it by hand. I have no idea why it's there. It's like the same thing with standard deviation. Like, what's the point if your calculator can do it? And your calculator can do it. So we're going to go ahead and talk about how to do that in just a moment. But I wanted to point out to you, actually, you might recognize what these little things are right here. Do you recognize what those are? Those are finding z-scores. Yay! So there's a strong connection between R and z-scores. And there's a supplementary video if you want to watch that sort of goes into how that all works. We decided for the purposes of what you need to know to be successful at these particular topics, you don't need to know all the finer inner workings of R. But if you were interested, go for it. Check it out in the master document. So anyways, the long story short is you do not need to use this formula and calculate R by hand, okay? Like, it's nice that you can sort of look at it and see the z-scores, and if you want to watch the video and have a firmer understanding of what's going on there, great. But ultimately, at the end of all of it, you're going to use your calculator, and you're going to use a little function in there that's called ln reg, parentheses, a plus bx. That will calculate R for you. And so let's go ahead and actually do that, and I'm going to show you that right now. So let's go ahead and calculate R, because we don't want to do it by hand. That's nasty and not fun. So in order to calculate R with the calculator, what we're going to do is actually we're going to go into and double check that our lists are still the same. So double checking list 1, list 2. Those are the different values I'm using for our study hours, test scores. And then I'm going to go back to stat. I'm going to hit the stat button again. And this time I'm going to click over to the calc. And at first it might seem kind of like I want to use the 2var stats. That's actually not going to be where we're going to go. It seems like it's like I'm using 2 variables. I always used to go to 1var stats for finding like means and stuff like that. I don't actually want to go there. I want to go to ln reg. Not this one, although it will work for you, but we are very specific about which ln reg we want to use because it's kind of like the stats way. I don't even know why this one is here because most statisticians actually use this ln reg here, a plus bx. Ultimately, it finds you the same thing, but it is a little confusing that they kind of swap the meaning of a. In one of them, a is the slope, but in the other one, it's not the slope. So it's a little confusing. So I like to go with number 8, okay? So you can either arrow down to it or you can just literally type the number 8. And then what we're gonna do is we're gonna put in where our different lists are. So list 1 is what I'm putting along the x-axis. So I'm gonna press second and then 1 down at the bottom, and that's list 1. And then for some reason it already has y as list 2. I don't know why it had list 2 as both things. That's sort of weird, but anyways. But remember, if you accidentally flip-flop these, I just said that turns out you're gonna get the same R value, so. And then frequency list no, store the regression equation. That'll be something we'll do later on, but right now we're not interested in that. And instead we're just gonna hit calculate. And what it's gonna give me is what the A and B value should be, and they are, oh no, my R value isn't there. What is going on? I did this on purpose. Maybe yours did. Maybe yours popped up and you were like, what is wrong with your calculator, Mr. Schultzen? I did this on purpose because some of your calculators may not display R by default. And I wanted to show you what you could do to make that show up. And right now, I don't have it showing up. So let me show you what you need to do, because finding R is actually pretty important. So what you're gonna do actually is you're gonna hit second, and then you're gonna go down to the 0, which means it's actually gonna take us to our catalog. So now, here it is, we're in the catalog. Catalog is where literally every single function is in alphabetical order. We wanna go down to a thing called diagnostics. Do not start arrowing down because that will take you forever. What's kind of cool is up here, maybe you noticed, there's a little capital A that showed up right there. That means that we can use the alphas here. There's all these little green numbers, letters all in here that are the different letters of the alphabet. And so what we can do is actually hit any one of those letters and it'll jump us down to that particular section of the catalog. So like as I said, I want to go to some diagnostics is the name. So I'm going to press the D, which is this matrix x to the -1 button right there. And it takes me down to my diagnostics, or sorry, to my Ds. And then I'm just going to have to arrow down to diagnostic because it does not actually, understand if you press like DI real fast. It doesn't work. So anyways, we can see there's a couple of diagnostic options, off and on. Currently, since my R is not showing, it is off. So I would like to turn it on. So make sure your arrow is pointing towards diagnostic on and press enter. It'll take you back to the home screen and we need to press enter again to make that command actually go through. You'll know it because it says done. And then we're gonna go back and do the same thing. So stat, calc, number 8, should have saved everything that I already had there. So I'm just gonna go down to calculate and press enter. And now I have A, I have B, I have something called R squared. Yes, that is literally just the square of the R value, which we'll talk about in the future. And then R equals, and there you have it, 0.7522. I like to go to 4 decimal places with R and R squared. So, you know, just a cool, like, and I do that too with like probabilities and stuff like that. So it's okay to rounds, and I go with 4 decimal places. So there you go. That's how you find R. So I hope that helps. So there you go. That's how you're going to calculate R, not by hand, but by using your calculator and doing just what we just showed you there. So as we found out, our R value is approximately 0.7522. And as we sort of compare that with sort of our sort of chart up here about strong, weak, positive, negative, we know now it's positive and fairly strong because it's not too far from the 0.8. That's pretty good. All right, so that is all for this video. Again, you had some things you had to answer. Make sure you go back and answer those if you did not. Come in for class. We're going to talk about sort of how you responded to those and your understanding of these things. See you in class.